stream. So I need to leave that and go to 151 and go to, no, we'll go to the office. I'll lecture from my office. That seems reasonable. So office, and turn on camera. Right. So, right, and just checking my audio levels. Audio levels are good. Streams there, chat streams there. Discord chat is there. Console. Discord chat. Aha, Discord chat. Hi. And I need to bring up my OBS chat. My stream chat next to it there. Stream chat, Discord chat, got you people. That's all lovely. And the wrong lecture. That's not the right title. That is the wrong title. I need this title. This one. Nope. File. Open. 3. There. Move to there and go present. Right. They can hear me, you can hear me, stream can hear me. The right lecture, rather than scaring you with being second years. Okay. Right, let's get underway, seeing we're a minute past. Right. Okay, welcome to the Thursday lecture, everyone. I know you saw me yesterday, so this is kind of be a pretty quick turnaround. Hopefully you've all seen the assignment. Some of you have started doing tutorials. Yes, tutorial people, yes, there have been a few. There are more this afternoon, immediately after this. There's more tutorials. You should hopefully be introduced to the first worksheet and the first assignment. Note the first assignment is due next week, so we get going really fast. Hopefully the assignment should be completely doable with everything I said yesterday. Today I'm adding new stuff and adding more things which aren't of that first assignment that's due next week, but is more around processing and more content. So as I said, I am Twitch streaming as well as on the Discord. So if you're people on Discord can watch me there or on the Twitch stream. So if I get along to my actual lectures, bang, and haha. So keyboard functions. So this was the slide I missed yesterday. So just like the mouse, right? Because you know how I showed you that we can interact with the mouse, we can move the mouse around, it does stuff on screen. You can also press keys. Now, keyboard handling is actually quite complex because what you'll notice about keyboards is that when you press a key down, there are multiple things that are happening. One is I press the key and there's an electrical connection that's caused by a switch. As the key gets close to the switch, it then makes a spark across the connection, and then it has a blank spot, and then it makes possibly another spark across the connection, and then it finally connects. So there's a little bit of flutter. There is a little bit of noise in the press, right? Luckily, you don't have to deal with that. The keyboard deals with that. But if you look at the raw events that are occurring, there's this wee kind of jaggy bit at the start, and then I'm holding the key down, and then there's a wee jaggy bit at the end. But that means there's a key press event. There's then not action event until I lift the key up again, right? So there's a key press and a key release. You can work out if the game you're playing has worked out how to deal nicely with keys if you press left, then press right, and then release left, what does the game do? Right? So I'm saying I want to go left, I'm saying I want to go right. Then what do I do when do I go right while still holding down the left key? Right? If I then release the left key, right? Sometimes when I release the right key, it will then face me left and make me running left, because it kind of didn't process the release the left key, because it wasn't keeping track of that. It was only keeping track of the most recent release, and the most recent release was the right release key. So key processing is actually quite a tricky thing. In the side scroller game we do for assignment 3, you will have to deal with key presses and pressing space to jump and those sort of things. So understanding that you can interact with the keys, there is a key pressed and a key released. They are like mouse pressed and mouse released. They're a bit like the mouse buttons. You can also ask about the key codes and what key was pressed. So when you get a pre-pressed, you can then say what keys are down. And so there are ways of kind of interacting with the information that way. There's key typed, which is specifically for input fields where you're typing characters, right? So that's why it's key typed. And it ignores all of those green and orange, well, it ignores the green keys, those modifiers, and the purple keys, those function keys, right? Those are not typed characters, those are control characters. So key press and key release works on those, and they give you a key and key code, but typed only does keys and it only does the typed keys. Okay, so it's a different way of handling, partly because when they first added the keyboard handling, they were only interested in as a field entry, so you could type your name in, so that nobody has the right arrow key in their name. So why would we include that in the keys that you can type? Right, so it was a limited set. And then they went, oh, actually people want to control this with special characters, so we'll add that other set. So it's a kind of 2 layers. So if we look at interacting with keys, this is a very simple code here for interacting with keys. Pretty much all of the code I've gotten here I put into the GitLab, and there should be a link on the ECS wiki site to the GitLab. You can go there, you can see all of this code is there, so you can just edit and play with it. So I set a background color, set the rectangle being centered, so that center, what does that mean from yesterday? Drawing from the center and make it 50 wide, so it's kind of 25 that side and 25 that side of the center line. So it's drawing it in the center line. I then started off at the center of the screen, so this would start in the center of the screen, and I have a key pressed, check out which key it was, decrement X, increment X. Pretty simple, right? And this does not do collision detection. This does not do bouncing off the edge of the screen. This does not do gravity. It doesn't have a lot of those things. It is just direct editing what you see on screen. Yep.
How come you're using processing in Microsoft Visual?
How come I'm using processing in Visual Studio Code?
How are you doing it?
How am I doing it? So there is a Visual Studio Code plugin that you download for processing. You tell that where your processing file is, and you also tell, I also tell processing there's an external editor, and I point processing at Visual Studio Code and Visual Studio at processing.
You can do different languages on
So in Visual Studio Code you can do other languages, yeah. So this is a default text editing environment. You do Python, C++, anything you like in it, and processing is one of the languages you can do in this. Of course you can also, and I do have on here, the standard processing environment, right? There are advantages in the Visual Studio Code environment. So if I go into code, it might take a moment to load because I've got far too many things active. But if we have a look at code, one of the advantages using code, that's actually me doing stuff in Godot, because I use it for my Godot programming as well. But if I go open recent, I can go into the lectures for 151. And fingers crossed that's the right one. So here you can see the list of my code. And so Okay. Yeah, so that's my markdown, my readme markdown. If I click on the arrow code, I can actually see the arrow code there, and it means that I have the like a list of all the programs that I have, and it's easier. And I have GitHub Copilot running, and so when I hit the end of a line here, it does crazy things like if it's going to connect with. Oh, my Copilot's disappeared. It will suggest code as well, but we don't need to see that. So, and it means that when I press play here, it sends this code to processing. Processing spins up and runs the code. So it's using that interaction. Eventually it runs. Honestly, it does. I'll have to check that. It seems processing is having a fit and not liking me. But so this is why I do it there. But hopefully you can understand all that code. Make sense? Good. We can draw parts of code. And one of the things I realized is as I was working in this, that I believe is still an image grab. But for accessibility reasons, having images of code is stupid. So later code, I'm actually copying and pasting the code itself and putting a black background on it. So hopefully it will become more accessible. But here, drawing arcs, you can see 200 by 200. I can have the ellipse in the top corner, but then I can start programming just parts of the ellipse and draw those arcs. And again, these are all in radians. So when you calculate these out, you've got pi over 2. So that's half a pi. You'd think half a pi was half of a circle, but unfortunately mathematicians aren't that clever. So half a pi is a quarter of a circle. That looks like a quarter pi surely, but no, it's a half a pi in radians because it's half a pi around there. This is the 3/4 pi, and this last one is of course 90 degrees turned into radians. I don't know why it decided to colour those differently, it just did. But that's the shape that you get, right? So again, you can control what gets drawn in various different ways. And finally, after all of that time, processing actually came up with, except it's too small because I can't move it, the arrow. But that means I can do that later. So radians, hopefully. You guys were introduced to radians at high school at all? Vaguely, as like, oh my god, degrees are easy, radians are crazy, why are we using radians? And because it makes some maths easier, right? And programs like this use radians, and there's certain good reasons for that radians make some of the calculations easier. But here, in processing, full circle 2 radians, 2 pi, the word 2_pi is a known constant, so you don't have to type 2 times pi all the time. You just use the constant name. And again for pi, half pi and quarter pi. And there is that, radians. So one of the things that I'm adding that we didn't do last year, but I'm adding now, but you'll do in assignment 3, is dealing with sprites. I'll talk more about animating sprites and how sprites are used in graphics later, in my later lectures. But at this stage, that's interesting. I've got that's the soccer ball behind me. Sprites, there's a type called p-image, right, which is a processing image, and it has a bunch of features that allow you to do load image, and you give it a path, and then when you want to draw, you do the keyword image, open the thing you loaded the image into, and its location. That location is the top corner of that sprite. And by default, it will draw it at the size of the sprite, right? Because the sprite comes in as a JPEG or a PNG that's 260 pixels by 260 pixels or something like that. It'll just draw it at that size, whatever size it was when you loaded it. So I put ball in the directory with the processing file, and you just call it directly. If you put it in a subdirectory, just call the subdirectory. That's just the path. And as you can see, it will just draw the ball. So that means you can grab any sprite, any image from anywhere, If it's got an alpha background, that's great for PNGs because then you can actually get a ball shape rather than having a ball on a big JPEG square, which would look pretty ugly. So that's the way you can load in images, and you move them around, place their XY position just like you would any other object you're animating. So and what we can do is we can start looking at how we would actually use some of this to do some coding. So now I think, I don't know if I actually included the bouncing ball in the code that I gave out. Did I include it? Did someone find that bouncing ball code in the code? I forget if I pushed it. Is it in the repo or not? Oh, if it's not, that's all good. We can keep going. So this can be done. So drawing a ball, I've now shown you a JPEG of a ball, but we can a PNG of a ball, but we can also just draw an ellipse that's a ball. Right. So if I jump over now, do you want me to do this in Visual Studio or processing? What's your preference for me to do this in? No preferences? Okay. So if I was doing this myself, right, so the real version of me rather than the lecturer version of me, what I would immediately do is I would go to ChatGPT and jump in and go, because I do ChatGPT stuff and because I'm doing a bunch of stuff for the university around ChatGPT, I would jump into ChatGPT, I'd turn on ChatGPT 4, and I'll just leave it default. I won't worry about the code interpreter or the other plugins, and I'd say, so draw a ball, move it straight, bounce it off windows, and add gravity. So in processing, draw a ball, bounce it off the side of the window, add gravity, and what else did we want to say? Oh, and interact with the mouse. And interact with the mouse. So what processing would do is it goes, oh yeah, no, sure, I know, what GitHub ChatGPT will do if I just make it go a bit bigger. So let's see, let's review what ChatGPT thinks is a good answer to this. Right? Now, if you're using ChatGPT and you're asking, or Bard or anything, what you probably want to do is ask it for 3 different ways of doing something. Right? Because if you ask it for 3 different ways of doing things, it will show you one way, and then it will show you a different way, and then it will show you a third way, and you can compare and read and learn about the different approaches to solving a problem. Right? So, in a modern programming approach, this is what people are starting to do in industry. But the problem with doing this is, there's quite a bit of code here, and a lot of code you might not understand. So blindly copying and pasting it in won't necessarily mean you learn anything. Right? But you can look at this and go, okay, so if we go through this code, are you happy to go through this code rather than me just type it out myself? Okay, yep. So we have, as you see here, we have a p-vector position, velocity and acceleration. Wow, it's wanting us to do a full system here, right? Now, rather than hacking about with just let's move the x, let's just x to x plus 1, it's doing the full, oh wow, you want to do physics. So we're going to add position, velocity and acceleration. We're going to have a radius and a color. We're going to create an object, which is a ball object, which has a radius, and I have the vector you give it, you can get its position from the vector you initialize the object with, and you're setting up a random position and a random vector and a color, which in this case is red. I have a run, which is update, check, and display, and then I have an update function, which grabs accelerations and adds velocities, and this is much heavier weight than I was expecting to have to do, right? Because it went, oh, you want all of this stuff? I can program that. So here, you might get lost in some of the things, checking edges, that looks reasonable. So height and width, that looks good. It doesn't seem to check, it checks height, position x width and position x versus radius. So else if. So I'm not sure what it's doing with that last one there. And then interact with the mouse. It does some direction normalization thing and a multiplication. It then initializes the ball. Set up, draw, mouse pointer. Right, mouse pressed. Okay, so this is a big program that it's written, right? This is far more complex than I'd expect you to have to do at this stage. This is one of the challenges of if you just let the AI do stuff, it'll produce a whole bunch of code you might not understand and you might not know what it's doing. So, if we could actually say, wow, can you make that simpler? So let's see, well, can you make that simpler without the physics? Right? And it might go, okay, so so let's do a simplified version. Yep, that's looking better. So this is the sort of thing. So as you can see, it will quite happily generate me code. Here, this looks much more like code I'd expect you to understand. Okay, so if we have a look at this, it creates a float ball x and a float ball y. Right? So it could be an integer or a float, it's a position. Ball size is 50, and we have a dx and dy of 3. What do you think the dx and dy are doing?
Direction x and direction y.
Direction x and direction y. Well picked. Excellent. So this is just saying, okay, it's moving 3, and which way will 3y be? Up or down? Down. It'll go down, so it's going down an angle. So we set up a ball size and we give it a direction. We set up with a 800 by 600 and we put the ball in the center by going half width and half height. We then do a simple draw where we update the ball's x and y by those direction x and y that you picked, right? And that's what's going to happen every time. And then what we do is we do a check. If the ball hits the edges, then we make it bounce. So, can we decipher what this code is telling us? What have we got here? Ball x greater than width. So that's the ball x is moving across. Greater than width. It's going to hit the edge of that. Or, so that vertical bar, you've seen the vertical bar, you're happy that we had bitwise OR before we had a logical OR, because we did everything in ones and zeros, and so logical will get 2 bars. So that's OR ball is x is less than ball size over 2. That's odd. Why is it ball size over 2? What has this code done?
It's offset for the size of the ball in position.
It's offset for the size of the ball, but it's half the size of the ball. Yep. So it's offset for the half the size of the ball. And it's technically, and so what we'll do is we'll do the clever thing now, and I'll copy this code. Is it going to recognize that I'm actually clicking copy? Wow, something's going really slow. Copied. Right, and so now I'll go into processing. Oh. It's not finding that, so I'll just go into Visual Studio Code, seeing you guys are apparently happy with me to do it in here. So if I create a new file, right, yeah. Okay, so there is an issue with this. Is let's just grab one I know. Let's go into the arrow. I'm assuming you know how to do that, so I'm just going to be dirty and override it, and press play. So in here, what it's actually done, and if I minimize that, cancel, don't move. I was meaning to expand the window. There we go. So here, what this actually should be saying is it should say 0 minus, or 0 plus rather. because it's the left-hand side of the screen is at 0, right? So it's 0 plus half a ball width. But because 0 plus something is nothing, it's decided to leave out that bit. So because here now we've got width minus ball size, half ball size, and we've got left-hand side, right? Because this width is the right-hand side of the screen. But often what you'll find is people when they write code, they will get rid of bits that actually explain it. So technically you could think of this as left-hand edge plus half ball. And then what does this dx times equals -1 mean? Yes?
Reverses the x velocity.
It reverses the integer, that number, that is the dx. So the dx was 3. So when you multiply by -1, it becomes -3. Right? So ball was heading that way, flipped it around, head that way. What do we do on this next? So that is, if ball's greater than height, again minus half the ball width. Right? So let's see if this, and actually does it do flip color? Draw ball, fill there, ellipse, ball size, ball size. It's got rid, so this has got rid of, this has got rid of gravity, because I asked it to get rid of the physics, and it's got rid of the mouse interaction. So let's just press play with this and see where we go. And the window should pop up here.
Sure you don't have a processing thing?
I have a processing thing running, and I have another one that's just run, and then when I get rid of that, it'll now actually run this one a couple of times. It was just taking a long time to show anything. Come on, wake up, processing. So what we'd have to do to this code is we'd then have to add, right, it did show, and hopefully that looks like what we expected. Red ball, hitting the things, changing direction, and it just changes direction at that -3. Okay, so how are we going to add gravity? What would be a way of adding gravity to this? Right, so I close that down. So what could we do in the draw here? At the moment, it's just updating by that amount. What would be a way of making gravity work? Any thoughts? Yep.
A constant acceleration down.
A constant acceleration down. So an acceleration changes, what does an acceleration change? It changes velocity. So we could have a constant change of velocity. Right, so if we do that, we'll just close that down. And yes, I've pressed it too many times, it's going to keep creating windows. So what I could do is say, well actually, how about every time we just, and this is going to look really bad, I don't know if it has, but let's go ball Y. And I can find and close that, and my processing windows will actually catch up with me. Ball Y. So here, what's just happened there? GitHub Copilot down here has said, hey, I think I know what you're doing. I think you're about to add gravity. So it's suggesting code to me to add gravity. And it's saying I should increment ball Y by 1. Right? So shall we see how that works? And we'll see if it actually prints it on the screen, or if I have to go back here and grab it from here. So now, so 1 is quite strong, right? So 1's a big number, so it's going to accelerate down quite fast. It will bounce, but then it'll keep getting the 1. And let's see if that actually worked. So, it kind of worked. So but you can see that it seems to only be doing it, it seems to only do it when it's actually hit the wall. So it's now going down much faster than it is going up, right? But it seems to only be doing that change a little bit, right? So it's not constantly updating it. So that obviously isn't doing what we want it to. So ball Y, and so that's, right, I can see why. I'm setting these to dx. I didn't change dy, I just changed ball Y by 1. Right, so I wasn't updating the d value. So here I'll have to go dy. That's why you don't trust the AI to do everything. Okay? So let's make that a tiny increment, and I'll press play, and I'll get ready to move it very quickly to the screen, because it will move quite quickly. I should really put a spacebar check in it so I can pause it, and then when I press space it will press play again. Let's just see, it should be, come on. My machine is really slow. Okay, let's see. So, dung. Oh yeah, that's looking more like gravity bouncing. Right, that looks like gravity bouncing. Alright, so I just changed the dy by plus 0.1 each time. So that's, 0.1's not a huge amount of gravity. Why is it not slowly losing?
Because you never decrease its max velocity. It just keeps the amount of velocity it has.
It keeps the amount of velocity it has, so it has perfect elasticity when it bounces. Right, so this is a ball, this is like your super bouncy ball, right? Because you drop it and it gets 100% of the bounce. Right, so it never stops bouncing. That's not going to be true, right? So what we would actually do is every time I did that flip, right? Every time I did this flip here, I would, rather than multiply by -1, what could I do for the, let's see, for the height one? What might I do? Yep.
Multiply by -0.99.
I could multiply by let's just make it 0.9. Yeah, 0.9. Oh, I'll get myself back to there. So if I make it 0.9 instead of multiplying by -1, what that means is I will now only get 90% of the velocity I have. Right? So it's not a perfect bounce anymore. So now when I press play, we can expect, you guys can make predictions. I could do a place your bets now, but we can see if, and I've only got 20 minutes left, so I'll end this bit, but I'll grab this and move it across once it shows, and let's see if I can get it across fast enough. There we go. Oh, it collapsed. Now this could be because it's an integer, and when you multiply by 0.8 of an integer, when it's below 1, it just only goes to 0, and it goes, I can't be point of an integer, so I have to be a 1 or a 0, and oh god, I'm going to be a 0 now. So I thought, oh no, that should be a float, but there may be a ball integer. No, there should all be floats. Well, it gave me an interesting collision detection. It probably bounced twice and just did some nasty mathematics, right? So we've had some fun making, so we added gravity. We didn't add the mouse interaction, but we did, you could see it bouncing off the walls. You could see it moving in a line, right? Okay, so those are the sorts of things we do. So what did we see here? We saw velocity. So we had a position, and then we added some dx and dy, right? So this is, now these of course aren't the numbers you saw on screen because I didn't know what the AI was going to tell me. So this is vx and vy would be that dx and dy that we had. Now more correctly, we should actually say that the velocity is related to the change in time. So the new time minus the old time, we actually have a delta that we can use to say what my velocity was. That's why that 3, oh, I've got an echo coming in here. So that velocity was 3 per frame, right? But you have to kind of, you want a 3 meters per second or amount of speed. If you change frame rate, you wouldn't want the speed to change, and so you'd do this. How long was it? A length of time times the actual velocity amount. We can often represent that as a vector. P. Now, remember in the first example the AI showed me, it said, hey, there's a ball with a P vector. That's what a P vector is. It's an X and Y put together that you can keep that X and Y as a single thing rather than have an X float and a Y float and have them floating around being different. So that's what that's doing. And then what you actually say is the new position equals the old position plus the velocity vector of t2 minus t1. Okay, so that's the cleaner mathematical representation of what was going on. And actually you would see that if when we looked at the other code the AI generated, it saw a vector plus a vector, right? And it had that delta time update all baked in. Now I do have you until 2, so it's not 150 that we stop. So if we have a look at this, we have position, velocity, and acceleration. Someone mentioned constant acceleration for gravity. That's this one down here. Of course, gravity is 0 in x and 0.9 or 9.8, something or other, in y meters per second squared. So we generally do velocity is updated by the amount of acceleration. That's why I added to my velocity 0.1 to change the speed so it would go down at a constant acceleration. There is a jerk is the rate of change of acceleration. I don't know if they talked to you that at school. And then there's snap is the constant rate of change of jerk. And apparently because mathematicians have a very, very small amount of humour, they call them crackle and pop are the next ones because they don't tell good jokes. So this should come straight out of 102 rather. So if statements, you're happy with if statements, conditionals, anything else? Yep, good, we can move on. For loops, you remember for loops from 102? Excellent, use them. This is a while loop. As I said, this code is now copy and pasted, so it's actually text in the slide. But you can set an angle 1.0f. You remember what that does? Did you use 1.0f for last trimester? You can't remember, some of you did. The f says this is a floating point number, right? So that we f at the end of the number says, oh, it's a floating point number, treat it like a floating point number. While angle is less than 2 times pi, I could have used TOW underscore pi or 2 times pi. Angle, so the arc gives me position and then I angles and I just increment the angle by 1 radian and then draw another piece of pi. As you can see, it gets 6 and it's missing the difference between pi and because this is a 1, right? It's incrementing the angle by 1, so it's not able to draw that last section of pi because there's only 6 sections there and it's 6 point, yeah. So, yeah, that's why it doesn't line up nicely. You could work to make it line up nicely if you wanted to, but we'd have to change how things work. For loops and while loops. You learned both for loops and while loops last try? You remember them all? Yep. I asked my third years this question just earlier. When should you use a for loop and when should you use a while loop? Can anybody tell me when you use one or the other? Because you can see from this code, they are in fact identical. Yep.
For loops usually when you need like an increment of time and you do it outside of a while loop.
So the answer there is for loops you have the iterator, the incrementer, iterator, incrementer, same thing, bound into the for loop, and so it's cleaner, right? So it's sometimes what we call syntactic sugar. Actually, the reason we use for loops or while loops has got nothing to do with the compiler. It's got nothing to do with the computer, right? The computer really doesn't care because it will implement them identically, right? So just, that's not why you choose. You choose because you are communicating to other programmers. When you use a for loop, you're saying, I've got a collection of things which I'm going to work through. With a while loop, you're saying, hey, I'm going to do something until something happens. Right? And those are two different mental states of the programmer, and the code doesn't care. So a lot of what you need to learn as good programmers is how to communicate your mental state, what you were trying to achieve, to other programmers who come to look at your code. Right? So that's the difference between while and for loop, is what you want to say to other programmers who are reading your code, not what you want the compiler to do. We can then use the last primitive of the polygon. This is a begin shape and end shape. This uses close. And again, you can probably tell those are vertices. I just draw lines between each of those vertices, and when I close off the shape. Right, you're all happy with that? That makes sense? Good. We can use for loops to make regular polygons. So this is a regular polygon. Actually, it's not a unit polygon. I should change that comment. So 640 by 640. I then go through and calculate using cosines and sines with theta and widths to place a vertex. Why am I using sine and cosine there? What am I using them to do? So what do sines and cosines deal with often? They deal with angles and circles. So if I want to do a regular polygon, I want to put its vertices on the edges of a circle. And so the sine and cosine give me a circle that I then move a certain amount of angle around, and then put a vertex, move around an angle, put a vertex, move around an angle, put a vertex. So that's why that shape actually sits within a circle defined by this theta times half height, half width. Right? So actually, I would need height and width to be the same. If I make them different, it would be in ellipse and it wouldn't be regular. So yeah, but you can play with that. Nested for loops, hopefully you're all happy with nested for loops, and you can see me there using randoms in my color fill. So I get a group of random colors. If you're doing assignment 1, you'll be playing with random on your colors, and the random in the assignment, one of them isn't randomized, right? So one of them is a set value. So you don't have to use random in all 3 positions, right? And also you don't use the full range in all 3. Of course, we care about code reuse. So in fact, rather than just whacking things in as numbers and making ugly code, I would say I have a number of rows and I have a number of columns. Actually, I've got those around the wrong way. That is the number of columns, and that's the number of rows. Sorry, I've written my code incorrectly because I've got 12 and 12. So I will fix that because I've got that. I've done that standard mistake. It's actually columns first and then rows second. Rows are internal, columns are external, because columns go across and then rows do the number of rows. So if I'd given these 2 different numbers, I would have got it right, but I got the standard thing wrong of getting rows and columns back to front. Yes?
You said that we could get the code on the sides from the ACINS cookie code?
There should be a link to GitLab next to the lecture. If you go to the lecture schedule, there's a link to GitLab, and when you click on that, you'll have to sign in to GitLab, and then you'll see a repo with all the code in it. And then you can check out the code, you can clone it, or you can fork it if you've got things, right? So this code might be on there and it might be wrong. I might have to fix it and update the repo. Sorry, honestly, this shit happens all the time. So trust me, it won't be the first time you'll see that fault. I can almost guarantee one of you or all of you will do that at some point, where you'll get your rows and columns mixed up, right? It just always happens. It's really annoying. And the worst thing is because I've got 12 and 12, I wouldn't ever see it because it's the same number until some user out there decides to have a non-regular grid and makes it tall and thin, and it's wide and fat, and they go, your program's broken, fix your program. And it's kind of, oh God, that's right, I've got another issue I have to fix with my code. Here I've also got the size plus padding. So rather than just sort of automatically calculating that, I explicitly say I'm drawing this as size plus padding, and size plus padding, and size and square, and size and square. Because rather than just having those numbers with 20s and 15s, you don't know what the relationship between that 20 and that 15 are. Is it because there's 5 for padding, or is it some other reason it's 20, or some other reason it's 15? Which bits of these are linked, which bits of these are different? That's why when you use variables, you can explicitly say that. And to communicate to other programmers, it is better to leave this plus in here, even though it's another operation. Right? Even though you know, oh, that's a different number, I can just put a number in there, or I'll call it a new variable that's, Z, and I'll put Z in there. Right? It's going, no, don't worry, an extra plus in your code will not affect your performance. Right? It's just a plus, it's fine. Right? But you leave it in there to be explicit about where these numbers come from. Okay, so the last thing I was going to say, and I've got 5 minutes, so I can either do this or ask questions, is can we do a drawing of a snake game where we draw 100 circles, and when the mouse is moved, we draw those circles around it? So, do we have any questions, or do you want me to do the last 5 minutes of me coding this up? Someone wants me to code? Anybody have any questions first? Do you think you know how you'd do this? Right, so some of the code would be mouse X's and mouse Y's would be related to what we're doing. So now here I'm using version control. The version control has noticed that I've made a change to arrow.pv because I copy and pasted the code in there, and it's saying, oh, do you want to commit that code and send it up to the repo? The answer is no, I don't, because this was me hacking the arrow thing rather than doing it properly. So I won't commit and send that. But I would be able to go into, if I go in my folder here, I would be able to go into my snake mouse. Because guess what? I prepared one of these earlier. But what I can do is we can actually make a new one. And I'll pick arrow, I'll collect all of arrow, and I'll delete arrow. Right, okay, so what are we going to need in here? Do we want to do this with setup an interactive way? It's probably going to need, so we're going to need a set up. Oh, setup. Oh, and it should be a void setup, shouldn't it? Void setup. And let's see if Copilot gives me a suggestion. We could also see what ChatGPT suggests for it. I'm assuming you guys are using ChatGPT occasionally? No? Okay. Make a snake in processing with a white ellipse, 100 drawn, following the mouse. Right. Oh, I even spelt that incorrectly. Let's see how that goes while I go back and do my programming. Okay, so yep, I'll take some of that code. Copy code. Let's go in here. Okay, so let's see how much of this code we understand. So it starts by making, it makes 2 arrays. That's interesting. I wonder why it's made 2 arrays. Right, you know what an array looks like? So that looks like an array. So it's set a number of, at 100. It's got a float array, and it's on a second float array for some unknown reason. It's set the fill color to white, which is what we'd expect it to do, yes? Yep. And we draw background black, a for loop, shift array elements. So this is doing it in an interesting way. This is actually shifting the snake around, right? So what it does is it's updating each element to being the next element, right? So it shifts the snake around and makes the snake follow, and in the drawer, it sets add mouse coordinates to the end of the array. So it takes the end of that array and adds the mouse coordinates to it. right? So it draws from the tail of the snake all the way to the head of the snake. It draws all the way from the head of the snake all the way to the tail of the snake, but then because it uses that Y to shunt it, it shunts the mouse X and Y in, and it treats the position as an X, as where you have to record 100 X positions and 100 Y positions, right? So it hasn't recorded a vector, it's recorded all the X's and all the Y's. I don't know if that will work. Let's see if that works. And I'll just grab it when it pops up. Aha! So, found an extra character without a match. Yeah, that's because I was naughty and I did the whole grab the code before Copilot had finished actually writing it. So, it got to draw and it then didn't do the draw ellipse. Okay, sorry ChatGPT, I was too eager. There we go. Now we actually draw the circles. Now, what I've shown you there is an AI way of generating code. Your job is to understand this code, right? Because if you just blindly put it in, it will make mistakes and it will give you the wrong outputs. And let's see, so what it's drawing, so it also does this I divided by 2. You see that I divided by 2? What do you think that I divided by 2 will do to the ellipses? So it will make the tail of the snake smaller, because what it does is it makes the I over 2 of the ellipse, as the I gets bigger and bigger and bigger, it gets smaller and smaller and smaller. So it's decided that what it wanted from my snake game was to make a snake that has a tracking around, but then have the snake shrink over time. Now, what I could do is I could edit this code so that, and it's over time. Okay, so hopefully that was some interesting stuff. You can see how we can interact, and enjoy your labs. I'll see you next week. Yep.
So, two questions. The first one is, where are the tutorials?
So where are the tutorials?
Yeah.
That's an interesting question. I'm not sure where the tutorials are, so I'll just stop that.